This video covers section 8.2, Relations, Objective 3, Graph a relation defined by an equation. Another way to define a relation instead of a mapping, a set of ordered pairs, or a graph is to use equations like we did in section 8.1. When relations are defined by equations, we typically graph the relation in order to visualize how the variables are related. This also helps us identify the domain and the range. So graphing the relation negative x squared plus 9, y is associated with negative x squared plus 9. We learned how to graph these in 8.1. We always like to get the x or the piece under the square to be 0 and start there. That's the opposite of 0 squared plus 9. 0 squared is 0 and its opposite is 0, so that gives us 9. We like to go 1, 2, 3, 4 to the right of that. The opposite of 1 squared plus 9. 1 squared is 1 and its opposite is negative 1. And that's 8. The opposite of 2 squared is negative 4 plus 9. Which is 5. The opposite of 3 squared is negative 9 plus 9, which is 0. And the opposite of 4 squared. That's the opposite of 16 plus 9, which is negative 7. Zero, 9, 1, 8, 2, 5, 3, 0, and 4, negative 7. And then we expect the same thing to happen on the other side. When we plug in negative 1, that's the opposite of negative 1 squared plus 9. The opposite of 1 squared is 1, so we have negative 1 plus 9, which is 8. Negative 2 squared is 4, and the opposite of 4 is negative 4. And negative 3 squared is 9, and the opposite of 9 is negative 9 plus 9, which is 0. Negative 4, the opposite of negative 4 squared is negative 16 plus 9, which is negative 7. So now we see that this graph comes up and attains this highest possible point for the y values of 9, but it goes down forever. And those are the y values, so that's related to the range, where the x values are the domain. And we're seeing here that this graph continues to the left and to the right. We can continue to put more numbers in this and get an output. It's just going to shoot down pretty quickly, but it will keep going. We can't cap it off on the left and the right, which means the domain is from negative infinity to positive infinity. And since the y values go all the way down to negative infinity, in interval notation, we always go from left to right, down and up, smaller to bigger. So we go from negative infinity to positive 9, but we include 9. Finding domain and range is easier with a graph in front of you. So practice 4 is for you to try same kind of graph, a parabola, but when you switch the x and the y, whereas in the last problem we had the x squared and now we have the y squared, it changes the graph rather than going up and down. It moves it either right and to the left. Remembering to plug in y values and get the x's out of them, and then write your ordered pair as x comma y. I encourage you to press pause on your video and work this out, and press play again when you want to see the solution. Now that you've had a chance to work this out, I'll work this out with you. We like to make the piece underneath the square 0. So let's set y equal to 0, and x will be 0 squared minus 4. 0 minus 4 is negative 4, giving us the ordered pair negative 4, 0. If I plug in y equal to 1, then x is equal to 1 squared minus 4, which is negative 3. Negative 3, 1. If I plug in 2, then I have x is equal to 2 squared minus 4. That's 4 minus 4, which is 0. So we have 0, 2. Plugging in 3, we have x is equal to 3 squared minus 4, or 9 minus 4, which is 5. And plugging in 4, we have x is equal to 4 squared minus 4, or 16 minus 4, which is 12. All right, that's as far as we can go there. The graph is going to continue going up from there. And on the other side, we plug in negative 1, and x is equal to negative 1 squared, which is positive 1 minus 4, which is negative 3. Plugging in negative 2, we have x is equal to negative 2 squared minus 4, or 4 minus 4, which is 0. As with all parabolas, we start to see the points on the bottom portion. Negative 3. Negative 3 squared is 9 minus 4, which is 5. We have 5, negative 3. And negative 4. Square the negative 4 is 16 minus 4, which gives us 12. And 12, negative 4. So now we have the bottom portion of this parabola. And so this time, it's the domain that we look at, and is not all real numbers, because it starts at an x value of negative 4, and the graph goes to the right from there. So this is from negative 4 to infinity, whereas now the range cannot be capped off because it continues up and down. So we have all real numbers, or negative infinity to positive infinity. This concludes the video for section 8.2, Relations, Objective 3, Graph a relation defined by an equation.